All right, if we're told a Poisson distribution has a standard deviation of 1.34, well, I know standard deviation is equal to the square root of the mean. Therefore, standard deviation squared is going to give me my mean. So my mean is going to be equal to 1.34 squared. My probability density generating function then, well, I'm going to use this formula. This is what gives me my probabilities. So probability that x equals xi is going to be equal to my mean. So let me go ahead and calculate 1.34 squared. And we get 1.7956. And I'll raise that to the power x times e to the negative 1.7956. And then I'll divide that whole thing by x factorial. So I'm going to come over here. I'm going to store that answer as letter A so that I can then plug it easily into my formula. I'll make my fraction. So I'm going to have A raised to the 1, of course that's just A, times E. Let's click that again. No. Raised to the negative A, and then divided by 1 factorial is just 1. All right, so I get my probability, 0.298. I can repeat and do this for 12. So this is why I typed it in this way. Now it's going to be very easy for me to go in. I can do 12 factorial in the bottom and up top. I'm going to expect this to be close to 0 because, again, my mean value is pretty low. So that'll be 12. And then just to be clear, I'm going to insert a times symbol there. All right, so notice I have 3.89 times 10 to the negative 7. I'm not going to write the e in my answer. So 3.89, not 0. Times 10 to the negative 7, so a value that's really close to 0. X less than or equal to 5, I could either add up probability that x is 0 plus 1 plus 2, etc. But instead I'm going to use my CDF. So Poisson CDF. Let's see if it's going to let me put in a letter A. Fantastic. My x value here is going to be 5. And there we go. There's a high probability that my x value will be less than or equal to 5. And the probability is 0.990 to 3 significant figures. Given that I just calculated probability that x is less than or equal to 5, it's very easy for me to calculate x is greater than or equal to 6. I know that the Poisson distribution takes the values from 0 up to infinity. So probability that greater than or equal to 6, that's just going to be 1 minus the probability that it's less than or equal to 5. So I'll take 1 minus my previous answer. And I'll get 0.10. Sorry, 0.010. All right, now greater than 5, given that it's greater than or equal to 3. Sorry, greater than or equal to 5, given greater than or equal to 3. Well, if I think about my probability formula, that's going to be x greater than or equal to 5 intersect x greater than or equal to 3. Well, anything greater than or equal to 3 is also greater than or equal to 5. So really, this is the same as just saying probability that x is greater than or equal to 5. I could stop there. And then I'm going to divide that by my probability that x is greater than or equal to 3. So calculating this will be 1 minus the probability that it's less than or equal to 4. divided by 1 minus the probability that x is less than or equal to 2. So I'm going to come up here. I'm going to do it in a fraction. 1 minus my distribution, CDF. I've got my a again. This time I'm going to use 4. And then in my denominator, same idea. This time 2. And there we go. 0.135 is going to be my approximate probability.